Okay, we are going to find this antiderivative and using trigonometric substitution to eliminate this square root symbol in the denominator. If you're going to use trig substitution, my suggestion is to draw a little right triangle, labeling one of the acute angles theta. And remember this acronym, SST. You're going to either use sine, secant, or tangent. And you want the variable to end up in the numerator, not in the denominator, and you don't want the radical to appear in your substitution. So the hypotenuse has to be 5 because of this 25 minus a leg. So 5 is the hypotenuse. X is going to be one of the legs. Square root of 25 minus x squared is going to be the other leg. We want this to be in the numerator, and we want to use sine, secant, or tangent. And sine is the one that does the job because we get x over 5. Sine of theta equals x over 5. We'll use this later. Theta, therefore, is the angle that has a sine of x over 5. Solving for x, that's your answer for part A right here. Take the derivative. Dx equals 5 cosine theta d theta. We need something for x squared, 25 sine squared theta. And here's why we chose the trig substitution. We want to eliminate this radical. Substitute 25 sine squared theta for x squared. Factor out the 25. Replace 1 minus sine squared with cosine squared. Take the square root. Notice I put absolute value symbols here. But we're going to make the assumption that theta is in the first quadrant. So we'll drop the absolute value symbol. And now we're ready to do the substitution. You might want to put this 12 out front. Replace x squared with 25 sine squared theta. Replace dx with, whoops, I forgot to put the 5 here. 5 cosine theta d theta. If you move this 25 out front, you get this 300. The 5's cancel, the cosines cancel, and we're finding the antiderivative of sine squared theta d theta. So that is the answer to part B. To get an antiderivative for sine squared, we use this trig identity. The cosine of twice an angle is one of the identities for cosine of twice an angle is 1 minus 2 sine squared. Solving for sine squared, we get this. And if we take the antiderivative of that, the derivative of 1/2 is 1/2 theta. Kind of using a u substitution here. U equals 2 theta, so du equals 2 d theta. The antiderivative of cosine is sine. And then to get from here to here, we use the identity that the sine of 2 theta is 2 sine theta cosine theta. That's why this 1/4 became a 1/2. So there's your antiderivative for sine squared. But I got to still multiply that by 300. So here's 300 times the antiderivative of sine squared. I get 150. That's your answer to part C right there. And now to get to part D, we have to replace theta in terms of x. So here's where theta equals inverse sine of x over 5. Goes right there. The sine of theta and the cosine of theta refer back to your little right triangle that you drew at the very beginning. The sine of theta is x over 5. The cosine of theta, adjacent over hypotenuse, square root of 25 minus x squared over 5. These 5's cancel, leaving 6. square root of 25 minus x squared. So there's your antiderivative. I will include a link to a Desmos graph that shows you that you can verify this on Desmos. There you go. Hope that helped. If you have any questions, post a comment.